I wanted to do a really quick video on just the basics of forces acting on an object and how they relate to Newton's laws of motions. So let's say that we have an object sitting here. I'm going to call this a box, and it's just sitting on the ground. It's not moving, it's not going anywhere. If we want to talk about what forces are acting on the box, okay, so forces on the box. You have to be very careful because we only want forces that are being applied to the box. We do not want to look at the forces that the box is applying. So for an object like this, we have gravity pulling it down, and sometimes that's where people want to stop. But the problem with that is this would be an unbalanced force, which means, according to Newton's second law, if we have an unbalanced force, we would have to have acceleration in that direction. And our box is not accelerating, it's just sitting there. So we have to think through what is the counter force that is balancing out this force of gravity. And that's the one that a lot of times people overlook. Okay? There is an upward force called the normal force or the support force that balances this force of gravity. Essentially, you have gravity pulling the box downward, and you have the ground, or whatever it's sitting on, pushing the box upward. So the normal force, or the support force, is provided by whatever the object is sitting on. So in this case, it would be the ground. Okay, so the forces acting on the box would be gravity and the normal force. They would be, in this case, equal in size and opposite in direction because we have to have equilibrium here. We have to have them be balanced. Now, one thing that is not acting on the box that I often see people want to do is they say that there's a force of the box on the ground, acting on the ground, or maybe I'll put pushing. Now, yes, that is true. So gravity causes the box to push on the ground. But the reason that we would not list this as one of our forces is because it is not a force that's acting on the box. This is a force that the box is applying to the ground. So you have to make sure that you are very careful and you read closely and think through what are the forces acting on, or which object is causing the force or creating the force. So we would not list that one as one of the forces acting on the box. The only things on the box would be gravity and the normal force in this situation. Now, as far as how this would relate to Newton's laws of motion, we would have the first law of motion, which tells us that essentially until there's an unbalanced force, we will not have acceleration. So this object is stationary, which means all the forces are balanced. We have the object has some inertia sitting there. You have to have an unbalanced force to cause that acceleration. You could also relate it to the second law of motion, which says force equals mass times acceleration. We have no net force, which means we have no acceleration, and we have that in this situation. But one that it's not really demonstrating, because the question was only forces acting on the box, it would not really show us the third law of motion, because in order to have the third law of motion, we would have to indicate that we have the normal force, so the ground pushing on the box and the box pushing on the ground. But again, this is not one of the forces we are listing because the question only wanted the forces acting on the box. So we would not really have Newton's third law of motion shown based off of these questions. Now, Newton's third law is still present here, but based on the phrasing of the question, that's not what is being demonstrated. So let's look at another example here. Let's say we have the box again, but this time we have somebody pushing, somebody applying a force to the box. And most of the time in your introductory physics classes, you will be working in frictionless situations unless it's otherwise stated. So let's look at what this would look like if there was no friction, and then we'll go back and look at what could it look like if there was friction. All right, so the forces acting on the box. We have gravity. Okay, so here's going to be my force diagram. We have gravity pulling it downward, and we have the normal force going upward. We have to have those balanced. Now, in this one, the person here is pushing on the box. They're pushing to the right, so we would go from the dot to the right, so we have the force of the push. And in this situation, again, there's no friction. Okay, so then these would be the only three forces that we have acting on the box. Gravity downward, the normal force upward, and the person pushing. Okay, now you might be wondering, well, what's going to be balancing this force of the push? Okay, well, we have no friction, so we don't have friction working against it, and there isn't actually a force countering this one either. Sometimes people want to put air resistance down, and that's a form of friction. Okay, so if we had to describe the motion of the box, this unbalanced force right here, well, what it's going to do is it's going to cause an acceleration. So what's going to be happening is this box is going to start moving to the right, and then it's going to speed up, and it's going to speed up, and it's going to speed up some more. So it's going to be accelerating. So the box accelerates to the right. Okay? And that's because of this unbalanced force. Now, as far as Newton's laws that would be demonstrated with this, we would have the first law of motion, which is stating that an object in motion wants to stay in motion, or an object in rest wants to stay at rest unless acted on by an unbalanced force. Well, here's our unbalanced force, which has led to our object going into motion. So it went from rest, person starts pushing on it, causing an unbalanced force. Now it's in motion. We also have the second law, because we know that this unbalanced force is going to cause an acceleration, and that's what our second law is relating to. Okay, and again, we wouldn't really have the third law of motion here because the question was only asking about forces on the box. And in order to have the third law, we would be needing to talk about the box pushing on the ground as well as the normal force, the ground pushing up on the box. But we don't list the box pushing downward on the ground because that's not a force acting on the box. That is a force acting by the box onto the ground. Okay, let's do one more. So let's say this time the directions tell you that there's a person pushing the box and they are going at a constant velocity. Well, if we want to look at what forces are acting on the box, again, it's just a good habit to start with gravity and the normal force. And again, we have the person pushing. So you could call that the push, you could call it the applied force. Now, here's where we have to think a little differently. If we are at a constant velocity means the acceleration is zero. And in order to have zero acceleration, we have to have perfectly balanced forces. We cannot have any unbalanced. So we now have to have something to counterbalance that force of the push. Okay? Well, in this case, we would then have to have friction or some other force being applied from the right to the left. But in this case, it would be friction because there's nothing over here that is applying a force. Now our friction force is going to be the same size in the opposite direction as what the push is. So this time we would have four forces. And the reason there had to be friction in this situation is because we're at a constant velocity and there wasn't anybody else over here. Now let's say that they had another person over here pushing against, then this counter force might just be the other person pushing. Okay, so you do have to read closely, excuse me, and make sure you pay attention to these. Newton's laws of motion, again, we're going to have the first law of motion. We are at a constant velocity, which means the object is moving, but it's moving at a steady pace. It doesn't change its speed or direction. So we still do have Newton's first law of motion. An object in motion wants to stay in motion unless acted on by an unbalanced force. Well, we don't have any unbalanced forces, so this object is going to continue moving at its constant velocity indefinitely until there is an unbalanced force. Okay, and then we also have the second law of motion. Okay. Force equals mass times acceleration. So there was no unbalanced force, which means there can be no acceleration. So those two usually go together. Again, for the same reason as before, we wouldn't have the third law demonstrated in this example because we're only looking at forces acting on the box.